Bismillahirrahmanirrahim. In this lecture, we have to explain concavity, types of concavity. Further, we have to explain test for concavity and then discuss some example on concavity using second derivative test. First, we have to explain concavity. What is concavity? So there are two types of concavity. One is concave up and another type is concave down. A curve is set is concave up if the slope is increasing, in which case the second derivative will be positive. Also, the graph lies above its tangent lines. These two in the given picture are the graph of concave of functions in particular region. In these graph, second derivative will be positive. Now, concave down function. A curve is concave down if its slope is decreasing. Means in case of concave up, the slope will be increasing, but in case of concave down, slope will be decreasing. In such a case, the second derivative will be negative. Means second derivative will be less than 0. Graph of concave down is shown in the graph. Now, test for concavity. Test for concavity. Let f be a function whose second derivative exists on, on an open interval I. If second derivative greater than 0 for all x in I, where I is open interval, then f will be concave up or concave upward. Secondly, if second derivative less than 0 means if second derivative is negative for all x in I, again I is open interval, then f is concave downwards or concave down. Now we have to discuss concave up and concave down concept on some graphs. In the given graphs, concave down and concave upward are clearly given. So in the first region or on the first parabola, function is in this region, the graph is concave down. Here the second derivative will be less than 0. On the second portion or on the second parabola, second derivative is greater than 0. Means in first this portion, second derivative will be less than 0. But on the second position, second portion, below from x-axis, second derivative will be greater than 0. On the second graph, function is increasing, means first derivative greater than 0, function is increasing. And here the function is concave of. This means that by using the concavity test, second derivative will be greater than 0. On the second portion, function is decreasing, but uh, function is concave of, so second derivative will be greater than 0. On the below graphs, first function is decreasing, but function is concave down. So second derivative will be less than 0. On the second part of the graph or on the second portion, function is increasing, so slope will be greater than 0. But function is concave down, so second derivative will be less than 0. Now further, there are two graphs. On the first graph, function is concave of, so function first is decreasing, then function is increasing. So here the second derivative again greater than 0 by concavity test. On the second portion of the graph, first function is increasing, then function is decreasing. So on the whole area, on the whole region or on the whole interval, function is concave down. So here function is the second derivative of the function a will be less than 0. Now on the fourth graph, first function is increasing, then function is decreasing up to 3. Here function is concave down. So second derivative is less than 0. Then function is decreasing up to 4.5. Then function is again increasing up to 6. So in this region, function is concave up, so second derivative greater than 0. Then function again increasing up to 8. Then function is straight. So in this case, first derivative will be equal to 0. So uh, this means that 3 is inflection point. Also 6 point something is inflection point because here the concavity is changed. What is inflection point? A point on which concavity is changes. Function changes concavity from concave down to concave up or from concave up to concave down. Then this point will be inflection point. Now further, concavity test. To determine whether a function is concave up or concave down on an interval determined where second derivative is equal to 0 or second derivative is undefined. Then evaluate values to the left and right of the point on the second derivative number lines. For example, C is the point where second derivative is equal to 0 or undefined. So, from to left function is concave up and to the right side function is concave down. So, this is the inflection point. Now, on the second line, on the second uh, derivative line, so to the left side of C, function is concave down, and to the right side function is concave up. So concavity changes on C. This is again the point of inflection point. When the sign changes on second derivative number lines, there is inflection point. If the sign on the second derivative number line does not change, then C is not inflection point. Here, point C is not inflection point because concavity not changes from on the C on C. Because to the left side function is concave down, also to the right side function again is concave down. So C is not inflection point in this case. Example: determine the inflection point. Determine the inflection point for the given function f of x is equal to x power 4 minus 24 x square plus 11. Given function f of x uh, is first the first derivative of the function is equal to 4x cube minus 48x. Now, second derivative of the uh, function is equal to 12x square minus 48. Now, to find inflection point, second derivative is equal to 0. So 12x square minus 48 is equal to 0. Now divide by 12 on both sides, we get x square minus 4 is equal to 0. Now x square is equal to 4. By taking square root, x is equal to plus or minus 2. Now we have to check that either plus or minus 2 is inflection point or not. To check x is equal to 0, substitute x is equal to 1 and 3 on second derivative. Because if x is equal to 2 or the point on the number line, then x equal to 1 and x is equal to 3 are the 2 points to the left side and the right side on the from the x equal to 2 from x equal to 2. So put x is equal to 1 on the second derivative, we get minus 36, which is negative. Now if we substitute x is equal to 3 on the second derivative, we get 276. So in this case, second derivative is greater than 0. So x this means that x is equal to 2 is inflection point because here concavity or changes. Concavity changes in this point. Now to check x equal to minus 2, substitute x equal to 0 because x is equal to 0 is the left point is the left side point and x equal to minus 3 x equal to minus 3 is the left side point and x equal to 0 is the right side point. from x equal to minus 2. So f double derivative at point 0 is equal to minus 48, which is negative, and double derivative at point 3 is 276, which is positive. So again x equal to minus 2 is the inflection point. Now to find inflection point, substitute x is equal to plus or minus 2 in the second derivative. Therefore, it becomes minus 69 at x equal to 2 and minus 69 at x equal to minus 2. Therefore, the inflection point is 2 comma minus 69 and minus 2 comma minus 69. This is the two inflection point of the given function. Now, in this example, what should be the value of a for the function f of x is equal to uh, for the function f of x is equal to ax cube plus 4x square plus 1 to be concave down at x equal to 1. So we have to find the value of a if the function is concave down on the point x equal to 1. Analyze the function through the second derivative test explained in the in above. So first derivative is equal to 3a x square plus 8x. Now differentiate again. The second derivative of the given function is equal to 6ax plus a2. Now at x equal to 1, second derivative is equal to 6a plus 8. For the function to be concave down, second derivative will be less than 0. So this means that 6a plus 8 will be less than 0. So the value of a in case of concave down will be less than 0, less than minus 4 by 3. Now again, on the second portion, tell whether the graph of the function f of x is equal to e power x plus cos x is concave up or concave down at x equal to 0. Analyze the given function through the second derivative test explained above. Given function is f of x is equal to e power x plus cos x. So differentiate first time. This becomes e power x minus sin x. Now differentiate it again to find the second derivative. So second derivative of the given function will be second derivative of the given function will be e power x minus cos x minus cos x. Now substitute x is equal to 0 on the second derivative. F double dash at 0 is equal to e power 0 minus cos 0, which is equal to 0. Since double derivative at point 0 is 0, so from the definition above, we can say that the function is neither concave up, neither concave down. So at x equal to 0 is the point is the point of inflection for the function f of x is equal to 0, because here the concavity is changes. Now, on third portion, what is the slope of the graph for the function f of x is equal to x cube plus 4x square plus 1 at x equal to 0. So analyze the given function through the second derivative test explained above. So the first derivative of the given function f of x is equal to x cube plus 4x square plus 1 is equal to 3 times x square plus 8x. Differentiating it again to find the second derivative. Second derivative of the given function is equal to 6x plus 8. Now, at x equal to 0, second derivative is equal to 8. So this means that f double derivative at 0 greater than 0. Thus, from the definition above, we can say that the shape of the function is concave of at a point x equal to 0. Thank you so much for watching this lecture on concavity. Please subscribe the channel for more informative videos on analysis.